Yeah, dear participants, in this lecture we will learn various agrometeorological instruments. There are various parameters which you learn in estimating evapotranspiration, in determining evapotranspiration by measurement. So, in the field we will show you these parameters, how to monitor various climatic parameters, various weather parameters which are dealt. So, let us go to the field where we have installed these gadgets in agrometeorological station. These gadgets, these instruments have been installed and we will demonstrate you in the field itself. Yeah, in agricultural and food engineering department, we have established agrometeorological observatory. In agrometeorological observatory, it is of the size of 60 meter by 40 meter, where various instruments are installed to monitor data on rainfall, data on maximum temperature, minimum temperature, wet bulb temperature, dry bulb temperature, evaporation. We are recording data on wind speed, we are recording data on which direction wind is blowing, we are recording data on solar intensity, we are recording data on total sunshine hours, and then there are various other data which are important for irrigation purpose, for hydrologic studies. So, all kinds of data. Now, in previous classes which we have discussed about estimation of evapotranspiration, and where we emphasized use of these data, climatological data for estimation of evapotranspiration, where you have seen that maximum temperature, minimum temperature, average temperature, as well as solar intensity, total sunshine hours, relative humidity. These data were used to estimate evapotranspiration. So, evapotranspiration studies or for any irrigation planning studies, such data are very important. And now, we will be discussing each of these unit in detail. This is a Stevenson's screen. Now, Stevenson's screen is made up of wooden material, and in this Stevenson screen what we see here, these are the battens and they are inclined battens, so that air can easily go inside the house. Now, in the Stevenson screen we house dry bulb temperature thermometer, where we record what is the air temperature, and then another one is wet bulb thermometer. So, wet bulb thermometer, the water from this particular bottle, it is the transferring to this muslin wet cloth. So, that the tip of the bulb of the thermometer is kept in this muslin wet cloth, so that it monitors the wet bulb temperature of the air. So, this is these two temperatures, dry bulb as well as wet bulb temperature, this is used to determine the relative humidity of the air. Now, then in this particular device, monitoring minimum temperature and maximum temperature, these two thermometers are also housed. Now, we can see right now the minimum temperature as on yesterday when it was recorded, it is 19 degrees Celsius, whereas the maximum temperature in last 24 hours, means in last these 24 hours it was 33 degrees Celsius. So, then this particular device also housed hygrometer to monitor relative humidity of air. So, these data are very important in various equations. When I was discussing about evapotranspiration, the temperature data are used to estimate evapotranspiration. Wind is another a very important parameter for estimating evapotranspiration. Now, in wind causes the transport of water vapor from the evaporating surface to the in a particular direction. So, when we are interested to know what is the direction of wind, so this can be measured by, or this can be determined by using wind vane. Now, from which direction wind is coming? Suppose there is a vast water body exists in the nearby field. So, water body will transport, if water means wind is coming from the water body and it is coming. So, we will have the effect of cooler environment in that particular area, that will influence the evapotranspiration or vaporization of the water molecules, and this will affect the evapotranspiration. If it is, say, the surrounding area where we want to measure, and the direction of the wind is having a place where lot of desert or without crop land exists there. So, the environment or the microclimate of that particular it will be different, and it will have the drier climate, and that is going to affect. So, direction of the wind is also equally important when we are estimating, or when we want to know the influence of the wind on the evaporation process or vaporization process. As I told, wind is one of the important component of meteorological data, and wind causes transport of water vapor. Now, amount of the transport of water vapor will depend upon the speed of the wind. So, wind speed is measured by using an instrument called anemometer. Now, in anemometer there are 3 cups. These 3 cups are hemispherical in shape, and when a slight wind it comes, this causes the these cups to rotate around its axis. So, number of revolution it takes in a given time is directly proportional to the wind speed. In yesterday's class, I was telling about estimation of evapotranspiration, and particularly for determining the Pan coefficient. So, value of the Pan coefficient depends on the wind speed and relative humidity of the area. So, it is one of the important component, and depending on the magnitude of the wind, the transport of water it takes place. Higher the wind speed, more will be the transport of the water vapor. Solar radiation and the total daylight hours, that is sunshine hour, are another important component for evaporation and evapotranspiration or photosynthesis activity of the plant. So, the how many hours in a particular day, in 12 hours period, how many hours sunshine exist, that can be measured by Campbell Stokes pyranometer. So, here what we see, there is a ball which is made up of glass of 7.5 centimeter in diameter, and then below this ball there is a curved surface on a frame on which a this particular chart is placed. Now, this chart is placed, and this chart practically what happened, depending on the movement or position of the sun, the this when it is rotating, when the movement takes place, that is a, because it focuses in such a way that it burns the paper. So, number of hours total sunlight daylight hours are there, that is coming here as a burnt part, and this value is used in many calculations of evapotranspiration, or also this value is used for finding out the evaporation from a water body, evaporation from soil surface. So, the this gives information that how many number of hours in a particular day the sunlight exists. Measurement of rainfall by using rain gauge is another equipment in any agrometeorological observatory, and in all the agrometeorological observatory, Siemens type rain gauge, that is a non-recording type of rain gauge, is used. Now, this rain gauge has a standard size of the funnel, and it has 127 millimeter diameter of funnel. So, whatever rain it is a captured by non-recording type of rain gauge is collected in this funnel, then it comes. So, this is the bottom part of the funnel, then it is collected in a cylinder. Now, amount of water, whatever it is collected in the cylinder, is measured by using a standard measuring cylinder, and this measuring cylinder has got 200 centimeter square area, and volume or depth of water, we can say depth of water, directly whatever it has occurred in 24 hours is measured by using this cylinder. So, here it is a graduated, here the graduation scale is shown, these 1 to 11 numbers, this can be seen. Now, these numbers are nothing but depth of rainfall in centimeter in a particular place. Now, it may happen during active rainy season, then one has to take observation 2 times or 3 times during day in 24 hours. Soil temperature is another parameter which is used to find out soil heat index also how much is the soil heat flux it takes place and which direction and at what depth. Suppose there is a soil moisture at certain depth, this will influence the soil temperature. So, these are placed at different depths and this is made inclined so that it becomes easier to know that what is the temperature of the soil. So, these are kept 15 centimeter, 30 centimeter at depth, or it can go below 30 centimeter also. So, this is a manually recorded the soil temperature observation, and this is used for many research studies, how much is the soil heat flux it takes place, which direction, whether the and up to what depth the atmospheric temperature which is influencing the temperature of the soil. So, it will depend upon the porosity of the soil, it will depend upon the compactness of the soil, it will depend upon the bulk density of the soil, that is making difference, but the influence of the moisture content, influence of the vegetation, that also makes a difference in the value of soil temperature. These data can be recorded manually and also they can be recorded by in the digital form by using soil moisture sensor. So, this is a sensor based soil temperature monitoring. So, there is one sensor which is placed at 30 centimeter depth. In this one, this is a soil temperature sensor. This sensor is basically for knowing the leaf temperature. So, leaf temperature, soil temperature, air temperature, these informations are important for many research studies. Here we are seeing a pan evaporimeter. Pan evaporimeter, it is 125 centimeter diameter, it has a depth of 25 centimeter and it is placed over a wooden plank platform and it is placed at a certain height above the land surface, so that the transport of air can easily take place and there is a minimum influence of temperature, earth temperature or soil temperature on the pan. Now, the water in the pan is filled up to 20 centimeter and the amount of water evaporated from the pan, it depends on the solar radiation, temperature, and as we see, this is the surface. At this surface the temperature just near the surface is lesser. As we go higher, so this makes a temperature gradient. So, saturation vapor pressure and then air the vapor pressure of the air at the the lower temperature, higher temperature, this causes this vapor pressure difference. So, this vapor pressure difference, it causes the movement of water vapor in the atmosphere. So, in 24 hours whatever amount of water it is lost from the pan is it gives indication in the Stilling well. So, Stilling well is practically it is meant for showing the what is the amount of water it is lost due to evaporation. So, we are measuring the loss of water and then refilling, bringing it to the original position whatever it is there. So, there is a device where we are filling in the evaporation pan, and this is practically a one bucket in which the water is filled. So, amount of water which we are filling, here you can see there is a graduation, where graduation it shows that the how much amount of water it is being filled into the pan. So, here we can see here 0 centimeter, then 1 centimeter, 2 centimeter. So, means any amount of water which is lost, that is directly one can know. So, this we are every time when we whatever amount of water it is lost, we are refilling. So, in 24 hours these observations are of all the meteorological gauges. It is taken 3 times in a day. Normally it is 3 times in a day. So, 7:30 a.m., 8:30 a.m. as per the IMD recommendation, and 2:30 p.m. So, means the pan evaporation data are taken at 8:30 a.m. So, amount of water lost in last 24 hours is replenished by filling the tank by using this particular bucket. So, in this bucket it is already graduated bucket, and where these graduations show that how much amount of water we have filled into the pan. A screen is placed over evaporation pan to prevent entry of birds or any other animals. So, though this screen has influence on the amount of evaporation, so we are required to make correction, but this is required to keep above the pan, so that birds or other they do not disturb, and we can get correct observation at the end of 24 hours. Now, the surrounding conditions of pan, this also influence the pan evaporation. For this we are required to know what is the surrounding condition, and when wind is blowing, and what is when wind is blowing. So, from which direction wind is coming, and then what is the surrounding, where there is a grass, there is a some crop it is grown in the adjacent area. So, at what distance this adjacent area this crop is being grown, or it is all barren land. So, this influence the value of evaporation which is taking place from the pan, and accordingly the pan coefficient is used to estimate pan evaporation. We have seen equipment where the data are recorded manually. We have seen a rain gauge, we have seen pan evaporimeter, we have seen the data which are wind speed, sunshine recorder, or maximum and minimum temperature. So, those data are recorded manually. In this case, what we are seeing here, it is automatically data are recorded for all these parameters: rainfall, maximum temperature, minimum temperature, relative humidity, wind speed, as well as solar radiation. So, all these data these are recorded by using sensors in the digital mode. Data are put up recorded in a your data logger. It can be downloaded by connecting, and also it can be transmitted to the server. So, this is the arrangement which we have. Now, in this one the sensors which what I am showing you here, in this one we have got maximum temperature, minimum temperature, as well as dry bulb air temperature, also wet bulb temperature, and hygrometer. So, sensors are placed over and this is connected with the data logger. Then we have a pyranometer, and this pyranometer data are also recorded what is the solar intensity, and then it is coming to the data logger. On the top we see there is a wind anemometer sensor that record the direction of the wind as well as wind speed. So, here this is a data logger, and then this data logger is means getting the power by using this battery, and this battery is being charged by the solar panel. Now, the entire thing what you are seeing here, that is the wind speed and wind direction. This is a particular type of sensors where it is there, and then there is a arrangement for monitoring the rain gauge, there is arrangement for monitoring the air temperature, global radiation, and then there is a GPS antenna where this particular station is installed. So, all the data they are hooked and then being going to the a particular server where these data are being. Then there is a solar panel which provides the power to the system. Now, to we have in the previous case in manually recording data, we had a Simon type of rain gauge, that was the data which now this is a recording type of rain gauge which is working like on a principle of tipping bucket. So, the water which falls in this particular cylinder cup, and this water it comes to a particular position. So, when water it falls over there, it will this will make a particular count once it comes to this position. I am not putting here because it will be data will be going there. So, that will not be correct to get data because this is going to the main server. So, this comes to this position, and then this position there is a there are two these tipping buckets. So, one bucket is this one and this is the another bucket. So, once it tipped, and then number of these tips it makes, that is counted, and that counted means it is equivalent to a particular size of the drop which is equivalent to 0.2 millimeter rainfall. So, number of times it takes, it gives that how much, what is the depth of rainfall in a given time it has been recorded. So, this type of tipping bucket rain gauge is a recording type of rain gauge, and then data are recorded. So, these are giving more precise values and correct values, and then without coming in contact with the instrument, one can from the remote distance one can know what are the meteorological parameter of a particular place, one can know, and then according those data that can be used for irrigation purpose, that can be used for estimating the evapotranspiration or various water balance studies, hydrological studies that can be used. So, in the field laboratory we have seen various instruments where we saw temperature monitoring instrument, thermometer, which measures minimum temperature, maximum temperature, wet bulb temperature, dry bulb temperature. For monitoring wind, speed and its direction. You also have seen sunshine hour recorder, you have seen rainfall measuring gadget, that is rain gauge, recording as well as non recording type of rain gauge. You have seen automatic weather station, and in forthcoming lecture we will also demonstrate you lysimeter. So, Let us see, and then you can refer some of these books for this more detail about these instruments, and thank you very much.